Okay, good afternoon. My name is Steve Porter. I'm an account manager for Head Acoustics located in North America. Our office is based out of Brighton, Michigan. Thank you for joining. I'd like to welcome you to this webinar titled CAN/FD, FlexRay, Acquisition and Analysis. This is with Head Acoustics products. CAN/FD, FlexRay, Data Acquisition and Analysis. So here's our agenda going through the webinar this afternoon. We're going to introduce CAN and CAN/FD and FlexRay communications for those that are not familiar with it. Then we'll step into a CAN/FD FlexRay data acquisition agenda item, and then moving on to how to extract and use them in Artemis Suite and analysis. I want to preface this webinar by saying I am not a digital communications expert. As with most communication, there is a bit of translation required, but also understanding of vocabulary and syntax. So you may contact me or your Head Acoustics representative for more details, but I am only here conveying publicly available information, and that from Head Acoustics products user manuals, Artemis Suite help files, and application notes. So first part, introduce CAN/FD, FlexRay. So first of all, as an introduction into these automotive communication technologies, think of cars today as a complex computer network, one that happens to come with wheels. So on that computer network, there can be what's called OBD2 information. This is onboard diagnostics, revision 2. These are legal requirements for emissions, and they have standardized addressing, digital signatures, digital addresses for engine RPM, vehicle speed, and up to 8 other parameters. So CAN stands for Controller Area Network, and this is a data transmission bus where it has a certain limited digital byte size. Think of it as the physical network that carries the spoken word between the multiple processors and control modules on a modern vehicle. So this is highly customized. It's vehicle OEM specific, even model and option specific. We'll get into more of that later. And then CAN, by the way, CAN does provide sometimes faster polling, faster throughput for data than OBD2. So why CAN/FD and FlexRay? Why these additional communication capabilities when we already have OBD2 and CAN? Well, it's basically due to the coming flood of data in autonomous vehicles. When you consider cameras, radar, sonar, GPS, and LiDAR available on proposed autonomous vehicles, we're talking about 4,000 gigabytes per day, each day. And how does that add up? Well, one autonomous car providing 4,000 gigabytes of data compares to 2,666 internet users. So this shows the amount of data that could happen with an autonomous vehicle. So there's a lot of data that needs to be transferred, not only possibly from car to car, but within the car itself, amongst the sensors and various systems that you have in today's modern vehicles. So reasons for CAN and FlexRay: this provides for more data transfer across the communication bus at faster rates, and for drive-by-wire applications like adaptive cruise control, brake-by-wire, steer-by-wire, and other advanced driver assistance systems like ADAS. So as of Suite version 11, the Decoder project, or through ASM24, supports this AutoSAR, or this Auto Open System Architecture files. These are special XML files with an ARXML extension, and it's for use with CAN, CAN/FD, and FlexRay buses, or FlexRay buses, I should say. So what is FlexRay? So FlexRay was developed to be faster and more reliable than CAN. It is more expensive to implement than CAN or CAN/FD. It requires either 2 or 4 wires, depending on the architecture, whereas CAN always requires 2. And this does support up to 10 megabits per second. So it supports different topologies, different ways of connecting multiple electronic control units in different formats within a given vehicle. But it cannot handle long bus lengths, so anything greater than, it's either 5 or 10 meters. So not very good for cars and trucks. or trucks and buses, excuse me. So it does require a 5x or a field bus exchange format file. It's an XML format, and it's defined by the ASAM consortium. By the way, ASAM, you might be familiar with that ASAM ODS, is what drives the ATFX file format. So this 5x file contains configuration parameters, frames, signals, schedules, and also the coding at the bit level. So like, excuse me, so CAN-FD, so this is very similar to CAN, but it has a flexible data rate. The CAN-FD increases the bandwidth of the CAN bus protocol up to 5 megabits per second and increases the data section. It's also less vulnerable to hacking and also can handle longer bus lengths, 10 to 20 meters, for those possible uses in trucks and buses. So it does use DBC files like CAN and provides decoder information. And so in the future, ARXML files will replace DBC files. So some important differences from CAN. So the CAN-FD rate is needed. This is the data rate for the packets that contain the bit rate switch. So within a data packet, it says what the data coming in is being provided at. So there's also a sampling point and percentage. This is important when switching between the nominal CAN rate and faster data rate for CAN-FD operation. A value of 80% is usually sufficient. So termination is also important, as normally the bus should be terminated. This is especially important when you tap into a CAN-FD bus that is not in, say, via an OBD port. Okay, so CAN-FD continues. So due to higher communication speed, CAN-FD requires different capacitance. So on the hardware side, so changes in circuitry are required to compensate for this. Squadriga 2 has this upgrade option, but with Squadriga 3, which we'll be showing some operation with, and also with HeadLab, the LabDX input module version B, CAN-FD circuitry is already accounted for. All right, so moving on, we'll move on to CAN-FD FlexRay data acquisition, how to use Squadriga 3, and also how to use a HeadLab for data acquisition when HeadLab's connected to head recorder. So digital streams can be recorded with front ends that have these inputs available, but they do require ASM24 data preparation module, that's your Artemis Suite module, to either monitor or live extract, decode, or otherwise decode in head recorder, or extract and decode in Artemis Suite. So note of caution though, per the manual with Squadriga 3 and with any head acoustics device that does connect to CAN, the following cautions should be understood for any interaction with the CAN bus. So depending on the configured Squadriga 3 operating mode, operation critical components of the vehicle may be impaired if Squadriga 3 or other head acoustics front-end devices, and these components use the same CAN bus. So operating the Squadriga 3, again, or other head acoustics front-end devices on the CAN bus of a vehicle is at a sole discretion of the user. So OBD, let's talk about that first. This is pulled from the OBD port, and there's an example of an OBD port there. No matter what, it's a small trapezoidal connector. It is sometimes visible through a panel, sometimes hidden behind a door, sometimes hidden underneath behind a panel. You have to get in underneath the in the footwell in order to see where it's at. But no matter what, it still looks like that trapezoidal shape. OBD data is read by request only, and it must be requested before it can be received. So data transfer rate is limited to 20 Hertz total bandwidth. So for instance, a single request, you can get up to a 20 Hertz update rate. For two requests, say engine RPM and vehicle speed, you'd have a shared 10 Hertz update rate for each. So this might not be suitable for high slew rate data acquisition like wide open throttle, where you have a high change of RPM in a small amount of time. So no DBC file is required for OBD data. These are regulated digital addresses for 10 parameters, which means they're always going to be at a certain digital address. No decoder file, like DBC file, is required for it, but it does technically connect to a DBC file. The OBD DBC file is available upon loading Artemis Suite. So on Squadriga 3, this is configured on either of the CAN inputs, and on the top of the Squadriga 3, also from a hardware standpoint, it's the D-sub-9 pin connector. So in the software, though, in the interface, it's one of the two CAN buttons here. So some important parameters: the mode. This depends on the manufacturer, and you can see the Squadriga 3 manual for details on page 47. It's going to be one of these 4 options here. And the rate almost always is 250 or 500 kilobits per second. And that is going to be important to make sure you get the right information from the vehicle. So the Obd Pid rate, this is the update of the decoded signal. So how often do you want your screen to be refreshed with this information? Decode parameters, so you can decode or monitor, and that's what decode means on Squadriga 3, up to 4 signals. Now those PIDs, those identifiers, parameter identifiers, must be listed in this area here for it to be monitored as well as recorded. So only requested OBD PIDs will be recorded. They are not available unless requested otherwise. So very important there that not only do you have to be connected, you have to have those OBD PIDs requested. It's a request made from Squadriga 3 out to the vehicle. What is the OBD RPM? The vehicle then sends back the RPM from the OBD parameter. So I want to encourage you to make sure that you have data on your Squadriga 3 and on the file before continuing with recording. So would not like to just hook up and get going and realize after I've had my time with my vehicle, which is precious, I know, not have the CAN data on it that I was expecting, or OBD data for that matter. So speaking of CAN data, this can also be pulled from the OBD port or even another port on the CAN bus, and it does require a DBC file, this sort of a decoder ring, decoder configuration file. So these DBC files are unique to the vehicle model, powertrain, and possibly some options, ABS, certain types of power steering, items like that, adaptive cruise control. So something to keep in mind is you might not have just one DBC file for one given vehicle. So CAN data is mostly read-only. You'll see that in the next slide regarding the mode. The entire digital stream of the data is read. That's how head acoustics works with CAN data. It can be sifted through for specific parameters that you choose from the DBC file. The data transfer rate is up to the bus setup though, so you could have a high rate of 2000 Hertz or more for some, but low for others. So one DBC file could have the same parameter available, but at different data rates. So on Squadriga 3, this is configured on either or both of the CAN inputs. So you see CAN 1, CAN 2. You could take up to 2 CAN inputs on a given vehicle. One could be through the OBD port, one could be through another port in another part of the vehicle. So some important parameters: the mode, again, almost always listen only. Acknowledge starts the Squadriga 3 talking with the vehicle through the CAN bus, and as I mentioned before, a lot of that talking back and forth or that connection may interrupt other services on the CAN bus. So when in doubt, always start with listen only. The rate, this depends on the vehicle. Sometimes 500 kilobits is enough. It might be up to 1 megabit per second. There's also intermediate steps. I think 666 and 750 and 800 some is also in there as well. So the FD rate and sampling point, these are for CAN FD only. So as I mentioned before, further up the slideshow, slide deck, that sampling point and FD rate are related to CAN FD. So decode parameters. So you can decode, again, decode on Squadriga 3 means to monitor up to 4 signals. So Decoded signals can be used for triggers. So you want to start at 1,000 RPM and stop recording at 6,000 RPM. You could have that engine speed determined from a decoded CAN signal monitoring engine RPM. So you use a file here to choose a specific parameter on the DBC file, or even you can create a CenX file, Artemis Suite sensor library. So make sure that you have data, again, similar to OBD, make sure you have data on the Squadriga 3 and on the file before continuing with recording. Depending on your setup here and your connection to the vehicle, you should get a checkbox. It was grayed out up here, notice, and down here it is red. So you should see that change if you do have data coming into that CAN port. So recording CAN FD and FlexRay data with head acoustics. So where possible, connect via the OBD port. It is a safer port than trying to tap into it somewhere else. One can connect directly into the CAN FD bus through another tap, but again, be mindful of the possible need for termination. So also, depending on the connection and the front end's operating mode, critical vehicle components can be affected if these components and the head acoustics front end utilize the same CAN FD bus. I mentioned that before a couple times. So FlexRay, Squadriga 3 uses a DBFR generated using this 5x file. This is created using the Squadriga FlexRay configuration application. This is installed with Squadriga Tools programs. So if you go down to your Windows 10 search field and type in Squadriga FlexRay, you should have a FlexRay configuration option app come up. It'll bring up this interface. You click on this import 5x.xml file, and then once chosen, the parameters for that XML file should be available. So notice that the DBFR export required for recording and reading FlexRay data on Squadriga 3 is available in these locations. So only the frames that are specified in the DBFR are recorded. So it is vital that if you plan on getting FlexRay data, that you create a DBFR file from the XML file calling out what parameters that you're looking for. So FlexRay does require you to choose what you want beforehand. So up to 4 parameters can be decoded, again, monitored at once, and they show up in the values from the indicated fields here. All right, so recorder and head lab. So you'd need to make a FlexRay sensor using the 5x XML file in Sensor Explorer 3. Apply and create a new sensor from Bus Systems, FlexRay sensor. FlexRay signals window comes up where you choose the XML file, 5x file. And then from the 5x file, you choose what parameters that you want to read, and then click OK. And then from that, a FlexRay sensor is created that you can use in head recorder. So this is different from CAN. Again, FlexRay does not record the entire data stream. So if more than one frame is required to obtain all the desired data, multiple frames may be recorded along with all the data within those frames. Think of frames as like a basket. And if there is one data set that you want is in one basket and another is in another basket, so 2 different baskets, you may have more than just 2 parameters being recorded. You may get some extraneous other items in those 2 baskets come through. So CAN FD setup is similar to CAN with the exception of the flexible data rate field and sampling point. So the FD rate within the data packet is a bit rate switch indicator available, and then also sampling point, the difference between nominal data rate and the faster data rate. This is where that's communicated. Again, usually 80% is the sufficient value. So really there is no other difference. And by the way, this is page one of the pages from Squadriga 3's manual, giving you more detail. Okay, so that was data acquisition. So we've acquired the data either standalone with Squadriga 3 or we've acquired it with head recorder, say connected to head lab, the lab DX version B. So now we'll talk about using the FlexRay in Artemis Suite, FlexRay can FD, can OBD for that matter, and how we take care of it in Artemis Suite. So if the data was recorded without recorder, it must be decoded in Artemis Suite Decoder project before using it in any way. So if the data was recorded with recorder and the following option was selected, it must be decoded in Artemis Suite Decoder project. Sorry, the following option was not selected. It must be decoded in the Artemis Suite Decoder project. So in order to decode it, by the way, ASM24 will be needed to be selected in your license selector for your head recorder. So not only ASM00, but ASM04 in order to start recorder, and ASM24 will need to be recorded. You can record the whole CAN stream if you want to without ASM24, but you cannot live decode what it shows here without that ASM24. So if this option was chosen, the parameters as selected in the sensor will be added to the analog channel count in the recording. And this, I did confirm this does work for CAN as well as CAN FD, FlexRay, and GPS. So Decoder project in Artemis Suite. Decoder project is where all digital signal extraction happens. So it decodes the digital signal into analog channels. So this is good for CAN, CAN FD, OBD, FlexRay. It's good for trigger and pulse channels, as well as the direction angle sensor, ABZ type sensor, and as well also the GPS signals that can be recorded with various head acoustics front ends. So how do you get to Decoder project? Click the home button, and under the editing option, you can click Decoder project. From Decoder project, that opens up a document in the main window. It has a source pool, a decoder pool, and then a destination pool, along with a preview option if you choose to click that button. So original data recordings can be inserted into the source pool. You can click a number of items and drag and try and drop them into the sources pool. Something to note though, if there is no digital signal or data was not, there is no CAN signal, there's no TAC or pulse signal, there's no GPS, it will not be dropped, it will not be inserted into the source pool. So you can choose which decoder you want to pull from the pull down in the decoder pool. So for CAN, CAN FD, and FlexRay, a file selection window comes up where you choose the appropriate file. So all data in the source pool that have digital channels available, a green check will show up next to that. If there's items in the DBC file that do not have the green check, those items are not available in the source pool items. So these are available based on what's in the current source pool. These are not available depending on what's in the current source pool. Okay, so if parameters are chosen that do not have a green check, other indicators will be shown in the decoder pool. So notice the green, that means yes, it is on the source pool file. Red means no, it's not on the source pool file, or files, I should say. Notice also the yellow circle with exclamation point in it. This indicates only a portion of the decoder items selected are available in that source pool item. Let's say you added some items or you want to add some items to this decoder, click on the green plus sign. If you added some items that you want to get rid of, you can just turn off those items, uncheck them, or you can right click on those items and click remove. So one or more decoders can be inserted into the decoder pool. Let's say one's at a high speed rate, and one's at a medium or slow speed rate. You can use more than one DBC file. And those should then be sent to for one input source file, there should be one output source file with both those DBC files used to extract data. Okay, preview of the digital channels is available. So depending on what these have, for instance, this has 2 digital channels. We have 2 digital extracted signals possible. So the default preview length, this is the recording max or 10 seconds. So that's the default right now. So this file is only about 4.5 seconds long. Therefore, it only shows 4.5 seconds. If it's 100 seconds long, it'll default to 10 seconds, but you can modify that field and change that to whatever you'd like. So some properties of the items in the source pool, or sorry, in the items in the decoder pool. You can apply an interpolation or have none. You can also modify the sampling rate to an extent. So it'll always be a factor of the main max sampling rate. So for instance, 1,000 hertz here, notice a tilde, that means it's about 1,000 hertz. So at 48 kilohertz, it just so happens that 48,000 divided by 48, which is a factor of 2, is 1,000 hertz. If it's 44.1, it'll be a little less than 1,000 hertz sampling rate. If you needed this to go higher, you can change this to 10 kilohertz. It'll max out though. It'll just oversample, upsample the data, maxed out at the data rate that was specified in the DBC file. Okay, so the default destination pool item is a head data file. Basically, it extracts the data, adds it to the analog channel count, and creates a new HDF file from that. So the properties for the HDF file export are here. Main one is possibly removing the coded channels, which can help reduce file size. So other destination items are shown. It's basic creation of new files. ATFX is available as well as UFF. Okay, so extracted data, as pointed out, are added to your analog channel count. So we had a CAN plus one, so we had left channel 1 here, and then 2 and 3 were added from the CAN data. So there is no way to get a pulse channel from an analog channel. So for instance, taking this RPM from an analog channel to a digital pulse channel, that's not a possibility at this time. Also, yeah, so notice we have the left channel, the engine RPM with a throttle blip at idle, and the vehicle was stationary. Okay, so analog CAN channels can be used as reference signals or order calculations. So that's done in the source pool. Right-click, go to Properties, choose Control Channel or Order Control Channel. And here I have shown an RPM channel. Our RPM channel, was chosen as the reference channel. So we have an RPM versus time shown, as well as an FFT versus RPM. All right, so with that, before wrapping up, that concludes our CAN portion, if you will, CAN portion. But before we wrap up, I wanted to make an important announcement on our Sound Quality Analyst Certification Training Program. Right now, Level 2 registration is available. This is a way for you to get familiar with how to really dig into sound quality analysis, sound quality characterization. Wade Bray, our technical VP, is the content developer and instructor. We like to think of this as Wade Bray University. So I suggest you take a screenshot of this if you'd like, and to understand the links that it takes you to. Level 1 right now is available to anyone. But level 2 and 3 right now is only available to customers in North America. So take a screenshot of this and investigate if you'd like. Finally, we have introduced Heducation. It's a one-stop shop for, say, upcoming webinar schedule. So for instance, this Thursday, again, May 7th, we will have binaural transfer path analysis presented by our consulting engineer, Pierre Dubé. And in the next 2 weeks, by the way, an announcement is forthcoming on this, we will have our Presense, our NVH simulator webinar series. So we'll have a Tuesday and Thursday, May 12th and 14th, but then also our active sound design capabilities will be presented on Tuesday, May 19th. We also have our YouTube catalog. You can get to our NVH tutorials through this website. You can also download or view app notes, including one for, recording and evaluating CAN signals. So I have used that as a reference in the past, so please do refer to this, say, before contacting your head acoustics representative, should you have any further questions about CAN, CAN-FD, or FlexRay acquisition analysis. Okay, with that, thank you for your time today in reviewing this material. We hope that it was valuable and enlightening. We please